to then generalize it and make your product work in a holistic way, in a seamless fashion. Now, the last challenge I point out here is the forecast that we are doing, there will be no skills in those forecasts at the daily time resolutions. So the temporal resolution, however, when you take your management decisions, if you leave aside the operational decisions, most of the planning, you're still operating at monthly and seasonal scales. So what is relevant is, how do you disaggregate? It's much less of a complex dimension to the other two challenges that I said. Nevertheless, these probabilistic forecasts at monthly or 3-monthly, or even with dynamic approaches, we can do up to 2-weekly. On short-term scale, we will be doing sub-daily. So how you bring all of that umbrella together into the source is what is the next bit. Now, here are some elements which probably is more relevant for deeper discussions down the track between the Bureau and the eWater community. But what we are seeking is, just like you're talking of trial catchments, what we are suggesting here is that we must take some areas in different hydroclimatic zones where we test out these case studies. And we illustrate that your water planning and water delivery mechanisms are better off with the forecasting. Produce this evidence, learn from that evidence, and then trade our way forward. And that's the essence of the message I want to convey without going through all those dot points. But by and large, the idea is to move based on evidence using these forecasts into source models. Thank you.
Okay, so I'd like to open up for questions for Narendra from the floor. I think there's a roving mic.
It's a total, my great embarrassment running a modelling organisation that I'm not a modeller by trade, so I'm going to ask a dumb question, but what's the advantage of hindcasting over the actual historic data? Is that you can run different scenarios? Why hindcast? I didn't quite get why you hindcast and how that would help you generate new scenarios. You talked about it generating new scenarios. So I apologise if it's not obvious to me the answer to that, sorry.
Yeah, all right. Look, let's say you want to take a planning decision for seasonal water allocation over the next 6 months, okay? You don't have over the next 6 months the luxury of having real rainfall and evaporation data, which is the essential driver for supply side. And in a way, if you think there's a blind man walking with a stick, you take the stick off, the blind man doesn't know where to go. So when you take the observed rainfall out of this equation, the hydrologic models fall in accuracy quite substantially. Imagine that you got an accuracy of this as of now with the observed rainfall. When you take the observed rainfall out and put a forecast rainfall, your accuracy drops quite substantially. How much it drops? How will it impact your policy decisions? To do that, you need to have an a priori evaluation. Do I trust my forecast? Are they accurate and reliable? And hindcasting is a process where you go back in time. Imagine you're at 1980 and now saying, I don't know what's happening in 1981. So you test your hypothesis, you go back to 81, test for 81. So that's the hindcasting process.
So you're basically statistically testing at different points in your historic sequence against how good a prediction you can make. Okay, thank you. That explained it totally. Thanks for that.
Somebody else is going to rove, but...
Mark Henry. Just a question about your conceptualization, because you're looking at getting data from the Bureau system and you want to link it into the source. But given the fact that it's still at conceptualization, wouldn't you consider coupling it instead of linking it, so that you have the capability of saying, if source is going to predict different changes, say like in the water uses or something like that, then you can go back and see how it's potentially going to affect the metrology or one way or the other.
So did you say linking in a model sense or
Yes, because your concept is literally going just one way.
Oh, I see, okay.
It doesn't go back, so you don't have that coupled loop.
I guess the intention is that the Bureau focuses on the supply side. So what we have looked at, the stations that I pointed out, are those unregulated tributaries or locations upstream of storages. And there's a very strategic reason why we've gone that way, because as we know, the river systems model are very complex with management decisions built in. So what we want to do is give the supply side of information, work with the jurisdictions, and then see the impact of that, bring that intelligence back to ask a question how we should be generating these forecasts so that the products are better designed to meet the needs of source community. So that's the pathway we have taken. If you want to combine these in a modeling sense, I think it becomes a very big beast. You know, where do you stop? You stop at the streamflow forecasting side, then there's a climate side, there's a weather side. So there's a whole raft of things. So it is better, we believe, to link at the data level through a web service as opposed to trying to bring a super duper model that can do everything.
Okay, so it was already a conscious decision you took, yes. Huh? Okay, fair enough, yeah, because I thought if it's conceptualizing, let's conceptualize it well and then go from there.
Yeah, and we have actually started this service with the user needs analysis. We didn't go and started building this. We actually tested this out for a year. Well, in that case, thank you.
So I've got to get here because I've been told I'm not projecting well enough. Don't normally get told that. Normally get told I'm too noisy. So next is Andrew Frost, so another colleague from Bureau of Meteorology. So we're switching now to talking about the Bureau's reporting role rather than our forecasting role.
Thanks, Grace. And I'd just like to say thanks, Gary, for the platform here today to talk about our work. Much appreciated. Also, the words of Don this morning were quite inspiring, I thought, and the subsequent adoption across the board by a bunch of different groups is quite encouraging. So, yeah, thanks for the opportunity. So I'm going to be talking about what we're doing in Water Information Services branch. Where we're producing national water accounts and water resource assessments using something called the Aura system. Underlying that is some source software. So Grace mentioned that in 2007 the Water Act came through towards the end of the drought, where as part of that the water regulations were put up, which basically asks different organisations to provide data to the Bureau, and then the BOM to provide data to externally to everyone. So that's one function of the Bureau, which is purely data collation. And I've got an example of one of the products here, which is on water storage across Australia-wide, which is available through the BOM website at the moment. So that's one aspect of the water division, or climate water division these days, that was created as part of that role. But I'm not talking about data, and I'm not talking about forecasting, which Narendra's part of that team. I'm going to be talking on reporting and our role there, and the information services we produce in the Bureau along those lines. Okay, as part of the Water Act, the Bureau's now required to provide a national water account annually, and as a start, at least, we're producing a national water account across these different regions I've got up on the screen. I think it's 8, and it's published online. And as part of that, there's input from many jurisdictional agencies, many of whom are here today, help us do that and provide data to that. So here's an example of one of those national water accounts for the Murray Darling Basin, which is published in for the 9-10 reporting year, NWA 2010. Basically, you're reporting on the physical water flows for a particular region and sub-regions within an area. Sure. So and also for surface water and groundwater, essentially. And there's lots of other aspects to that, where we're basically trying to use the observed data as much as possible and model elsewhere. So rather than just report on that specifically on the surface water store, we break that down into much finer detail. Yeah. No worries.
That's good for a tall bloke like you. And me. There you go, mate. Don't be shy.
Is it on? Hello? Check 1, 2. It's much better. Okay. So yeah, I was just mentioning that we go into a much greater detail in terms of reporting on the different aspects of the surface water and groundwater stores, plus a lot of other things, and just a few snapshots from what's up on the Bureau's website at the moment. So here we've got groundwater inflows and the various in outflows for a particular region. In addition to the National Water Account, which is annual reporting on water use, we've got something called the AURA report. So AURA stands for Australian Water Resource Assessment. The first AURA report came out just recently, last year, and it's the summary report's just down there on the bottom, where we're basically putting the water availability for that reporting year into context over the last 100 or so years for a series of regions across Australia and nationally. So an example of what we're reporting on here is shown up the top. Basically, we provide estimates of rainfall, evaporation and water yield for Australia, and the difference that might be from the long-term mean, and how that ranks across the entire series of climatological and hydrological data that we've got. And that's, in this case, Australia-wide, but we then delve down into greater detail on that regional basis we've got there. So here's just a single example from the national overview that we've got, where we're putting out streamflow estimates for that particular reporting year, and that's using an underlying model that we're using. And from that estimate of streamflow, we then rank that for spatially to see how that sits essentially compared to the past. It's not just surface water, we're looking at groundwater as well. So here's a couple of examples of the different groundwater systems within the MDB and Adelaide regions. So showing the decreasing or variable trends for each of those. Okay. So how do we go about populating each of those reports? That's what our whole section's all about, producing these two major products which are legislated. So we've got data coming in through the water regulations, but we've got to meld that somehow to, we've got data available in certain locations but not everywhere. So we've got to be able to estimate it where we do need it, and we don't always have data everywhere, so we've got to use models. So this is just a conceptualisation of the water balance that we're trying to estimate. We're trying to estimate each of these fluxes across. We've got a surface water store, a landscape store, groundwater store, and the water transport system. We're trying to estimate all of those things as part of the National Water Account, and more of a surface water landscapes sort of focus within the AURA reporting. So the question is, how do we do that? So the Bureau has a business need in terms of water balance estimation that we're looking in the past, we're not forecasting. We've got available data, we've got models to do that. But the Bureau requires a national water balance system because we've got all those regions that we need to produce the reporting for that quantifies retrospective. So again, it's for the past, we're not in prediction mode here. Water storage and water fluxes and their respective uncertainties. We haven't quite got to uncertainties yet, but that's what we're aiming for. Using the available observations, streamflow records, groundwater levels, etc., irrigation extractions and returns. But we don't have them everywhere, so we've got to use modelled data as well, using the state-of-the-art science technology. that's showing that the methods that we're using are up to standard compared to peer methodologies. So how do we do that? So over the last 4 years or so, I can't quite read what's being said there. CSIRO have been basically producing a new system called the Aura system. Rather than the Aura port I was just mentioning a second ago, it's the underlying modelling system and technology I'm talking about now. So through Orata, CSIRO are developing the Aura system to help us retrospectively estimate water balance using the available observations that we do have, and meld them to the model in the most suitable way so that we do actually conserve the observations where we do have them. So Orata 1 is finishing in June 30, but there's been a massive I guess, development effort as part of Orata, particularly on Aura, to support our new role within the Bureau. So here's a high-level conceptualisation of what the Aura system looks like. And there's a bunch of different components which I think Dave will talk about after I do. I'm going to focus on a few of the core ones around the modelling side of things, briefly at least. But I did want to point out that we're talking about a national water balance modelling system here. It's not a desktop thing. It's a much bigger thing with lots of other data feeds. In particular, I don't know which one actually points here, but on the left we can see BOM data in terms of national regulations data coming in. So we're estimating, having a modelling system that's running nationally. There's climate data coming in there as well. There's also potentially satellite data that's feeding into that, updating soil moisture stores, evaporation, etc. That's updating our landscape model. So it comes to the overall Aura system, which is in the dotted lines here. In the centre, which I think here, we've got the key components of the Aura system, which is a landscape component, which is almost like it's a distributed rainfall runoff model, essentially, or landscape model. There's a river model component and a groundwater model component, where we're trying to tie the observations that we do have to each of those. And we're doing that through a model data fusion and benchmarking system. I won't go into that in any further detail. And out the other side, once we've got our estimates of all the different water balance stores in terms of evaporation, soil moisture, stream flow, groundwater stores, etc., we can produce our national water account annually and our Aura report, which is currently coming out biannually. Okay, so as I mentioned a second ago, the key components that I'm talking about today are the landscape component of the three modelling components of the Aura system, which are the landscape component. It's a 5 kilometre gridded soil water store model, essentially, with that also produces, as opposed to sort of standard rainfall runoff model. So we've got a 5 kilometre gridded model, but it also produces ET, soil moisture estimates, and recharge discharge. So that's quite an excellent thing in terms of reporting for Aura purposes. It's currently coded in C# and time. And in terms of demonstrating that the methodology is reasonable or good compared to peer methodologies, CSIRO have been doing a whole heap of testing and development in terms of improving the model. So here we have our standard rainfall runoff models. The higher up this scale across all your different catchments, which is shown on this scale, the higher up that is to 1, the better the models are. Our standard rainfall runoff models here, calibrated locally, are sitting here, and here's 3 different sort of national gridded models. Now this was Aura in the very initial stages before it was calibrated, but through subsequent development and our first go at calibration, it's up and around performing as well as locally calibrated models. So this is a national model using the 1 parameter set across Australia. I find it quite remarkable that this is performing so well in the first cut. And I think that's going to come on leaps and bounds in the next year or so with a whole host of improvements that are coming through CSIRO at the moment. So it's actually quite exciting on that front. So Next, we have the river modelling component where, in addition to the landscape model, we've got a river model component to estimate river storage, reservoir storage, using available data. So we use available observations where we do have them, but use the model to basically integrate those observations and estimate other terms that we don't have, like losses to groundwater systems, etc. So the river modelling component is done by source at the moment. That's the underlying architecture, which has been exposed through CSIRO to run at this national scale. It's not running the source GUI per se, but it's been run in a different form, which Dave, I think, will go into a bit later on, and it involves standard things in that sort of field with river routing, reservoir estimation, surface water ground interactions, irrigation and flooding to and from landscape. So that's the key component that is in source at the moment. And